This conference will now be recorded.
Okay, guys, welcome on board. To introduce myself Ravinder. I have 13 plus years of experience as a SQL DBA. I'm working on MongoDB last since last 6 years, and I'm working on Azure SQL DBA as well last close to 6 years. And along with it, I do work on Postgres and MySQL as well. My profile is a multi-platform. I support multiple DB technologies. This is about like a little bit of information about myself. Let's get into the today's demo about Mongo. And today's objective is all about what is NoSQL basically. And MongoDB belong to NoSQL family, and what is NoSQL exactly. And when we have RDBMS systems in place with the sophisticated, and they are so successful since very long, and why we are getting the market and why we are seeing the market is moving towards NoSQL, what kind of use cases it is actually fulfilling over RDBMS. We're going to talk about that. Next, why we need, see the same case here. There are many advantages we are getting over RDBMS with the help of NoSQL family products. Basically, RDBMS cannot perform or cannot do the same job what NoSQL can do, which is actually giving a lot of benefits to the business. That I'm going to pick it up. What are the major reasons, and what are the so sophisticated features that are introduced in the NoSQL that are not there in the RDBMS? And we will see the terminologies, what are the different terms we have in NoSQL, and we do have like comparison between the NoSQL and RDBMS. Then different types of NoSQL databases like we have in RDBMS, like Microsoft SQL, Oracle, MySQL, Postgres, Greenplum, etc., etc. A lot of products are there. The same way in NoSQL also, we do have a lot of vendors who build their own NoSQL family products. Exactly, like given developed by many industries, many products and distributions in NoSQL family as well. And in RDBMS, the transactions will follow the ACID properties. In NoSQL, it will follow the base properties. What is the main difference between these two, which is very important to understand for us especially? All NoSQL families will follow the base transaction property, whereas RDBMS will follow the ACID transaction property. So these are the main agenda, guys. These are the main topics we're going to cover. A lot of things we'll cover in these words. Okay, each one will cover a very big, broader area. Especially, we'll talk about it one by one. Okay, so let's come to the objective of it. So NoSQL was introduced by Carl Stroji in 1998, and to name it as a file-based database. Actually, this is not a new thing in the market. It was introduced and invented a long ago, but there was no response from the market because we were satisfied with RDBMS products during that time. Like data generation nowadays is versatile. Like everybody has a mobile, everybody has a different device to interact with the, like internet and do the, data generation. So before, like 10 years ago or 15 years ago, people don't have a smartphones, smart devices in their hand. So data generation was limited, and your data was fixed in schema. Like you define something, you load exactly the same thing, because the UI interfaces are not given to the end users. Only the application used to be there. People used to enter the data in a fixed schema model. But now things are changed completely. Like everybody have a smart devices, and they have all apps which generates wide variety of data, and that wide variety of data does not have any fixed schema kind of. So that cannot handle by the RDBMS nowadays. Definitely RDBMS cannot take all sort of data. Like it only deal with the structured data. If you send any kind of data, it does not take it. You have to define the structure, then load the data. That's where the RDBMS, that's how the RDBMS would work actually. So we will see, guys. I'm going to pick a point by point in the next slide, so that you understand much better what is exactly the NoSQL, what is exactly the RDBMS. You get the fair idea, as well as why MongoDB is so popular out of all these, why it is gaining the market. Also, there are significant reasons. I'm going to pick up all those reasons as well along with it. Okay, NoSQL represents group of products and various related data concepts for storage and management of large data sets. Basically, MongoDB or any NoSQL products are made for handling the huge bulk data. All analytical data is running on the NoSQL platforms only nowadays. We are not using, RDBMS products for analytical or artificial intelligence data. Is always, run through the NoSQL family systems only nowadays. So to make you understand better, I'll try to pick up the architectures and then I'll come back with all the next slides so that you follow better actually. So if it is RDBP system, what happens? Let's understand this, guys. If you understand this, you understand most of the slides what I'm going to discuss next. If it is RDBM system, you stand up a very big machine. Okay, you will, like example, you have a three data drives and one log drive, and you're striping the data into three data drives. One log file is enough to generate the events or transaction details into this. So as the data is keep growing, what do? You expand the disk space so that you accommodate the ongoing data or increasing, like data is getting increased, you are keep increasing the disk. So you are keep loading the data, the disk will not perform well. IO will choke up, right? If you are keeping large volume of data in single disk, it will definitely not a good idea. So you introduce some more disk and you introduce some more files into the database so that data will get distributed so that you get the better IO. But if over a time data is growing and growing, you are keep adding the disk space, and like it happens, it will scale. Like you, as the data drives, you are increasing capacity is increasing, you are going to increase number of CPUs, memory, and the system. So when you keep increase more and more CPUs, what is a big problem with the RDBM system is all RDBM system nowadays are core based licensing model. How many cores you have, that many licenses you have to pay for the product. So as the data, see, RDBMS is capable of handling large volume of data sets, but there are problems with the large data sets keeping in one server with the RDBMS especially. So if you are loading large volume of data into single server, it will take up, it will process it, but it will become eventually very, very slow. Why? Because if you have 1 TB table or 1 TB database, you can do the rebuilding index over a weekend like Saturday, Sunday. If it is become 10 TB, 12 TB database, you cannot do the rebuilding index over a weekend. It takes days and days to do the rebuilding indexes. So for doing the rebuilding indexes, they cannot give the large maintenance windows, so where you cannot perform the rebuilding indexes, reorganizing indexes, and if you don't do it, the system won't scale up with the data. So RDBMS are very sophisticated, capable of processing the large volume of data set, but when it becomes too big, you cannot do the data maintenance. That becomes very, very headache for the anyone to do on a single server. So MongoDB came up with a different architecture where, irrespective of the data, whatever the amount of data, you can keep in a single system. Single system is into one architecture basically. They do follow the distributed computing model, not like a rigid one system concept here. Anyway, like you in case of like one server, you create one more standby for availability. I'm talking about data availability. You create one more standby, and the same data will reflect here. And if one server goes down, other server will pick up the load. That is something good in the RDBMS. Okay, but at any point of time, one server is actually writable. Like you can only write into one server. The rest will be standby, just a standby as a DR. But Mongo has a different architecture where it can scale with any amount of data. There is no limitation of data. It can, like this is a limitation. It can process up to kind of. You load petabytes of data, it will process. But there is something called replica sets. Using replica set, we'll build a sharding. Using the sharding, you can process any amount of data. There is no limitation. I'll explain the architecture. I'll come back to the slides, guys. I'm just giving you the architecture so that you understand what it is kind of. Then the slides will become easy to understand, everyone. Okay. Just try to follow this diagram, what I'm going to explain, how MongoDB is going to work basically in the background. Just I'll give a fair idea so that you understand well, right? So these are all replica sets. You'll have a config service again. What are all these? I'm going to explain. Don't need to worry. I'll give a fair idea about each thing so that you understand the whole point of discussion here. These are all Mongo servers. and these are the end applications basically. You just try to follow so that you understand at the end of it. I'll connect all of these diagrams anyway, what I'm discussing again. So these are all application, like end user applications or front end applications, whatever you say. Front end, front end app, I'll call it as. These are all Mongoose, we'll call it as Mongoose services. And this is a config server. And these are all called replica sets. We'll call it as a replica sets. So here, each replica set, like your always on groups kind of, if this goes down, this will automatically fail over and it start functioning from there. If this also goes down, other one will take up the data and then start functioning from there, which means that these two are the standbys. And here these are actually what happens, in this is a sharding architecture what I'm talking about. Okay, we are going to configure this in detail. I am going to talk about, I'm going to show everything in the product of this when we start the modules and all. So what happens, the front end applications will connect the Mongoose. Basically Mongoose is the point of contact for all the applications. The applications will hit the Mongoose services. Mongoose in turn will connect the config server. Config server will keep all the data addresses where the data is sitting, which chunk of data, which data you're trying to read, where data is sitting actually. So in sharding model, if you have a 100 GB table, or example 100 GB table, I have 100 GB collection, we call it as. So it will distribute the data equally. Here 25 GB, like everywhere 25 GB something, it will keep it. So data will get automatically distributed among all the nodes. You don't need to worry about it. 25 GB here, 25 GB here, and 25 GB here automatically. It is automatic distribution. Just configure once, it will take care of the distribution equally among all the nodes. So you are loading example in terms of our database terminology. If it is a one table, you sharded the table. The table, whatever the data you load into the table, automatically distribute into all the four replica sets. These are writable copies in the replica set, the front end I'm talking about. These are writable copies. So if I'm loading example 1000 records, assume a case 1000 records into one single table, we'll call it as a collection. So 250 records will show here, load here, 250 here, 250 here, 250 here automatically. The data distribution will happen automatically. I'm sending huge bulk data, and Mongoose will receive. Mongo will contact the config server. What are the servers are available? Then it goes and load the data into all the servers equally. And here data example, it become one single collection data become 10 TB assume a case. 10 TB means 2.5 TB, 2.5 TB, 2.5 TB, and that Mongo replica set is becoming slow. Why? Because data becoming more and more. So what do we do next immediately? If data is growing in the cluster, we'll call it as a cluster group, this one basically. If data is growing on existing replicas, what I'll do, I'll add one replica. Simply one command does this. Only one command will do the job adding into the cluster. When you add this one, 10 TB automatically divided by 5 nodes. Automatically it will share the load with this one. Like it is 25 TB now. Example 20, like 200 GB, 200 GB, 200 GB, 200 GB, 200 GB, 1 TB if you take a case. So we did not stripe the data to like move the data here. It automatically equally, like if you are a new node, it whatever the data is extra, and it is trying to, all the nodes will share the data and push the data to this node equally to balance across the cluster automatically. You no need to worry about it. Basically it does automatically. It is inside the architecture. It will take care of it equally, balancing the data, splitting the data, balancing the data will be taken care by inbuilt functionalities. So what I mean to, why I'm discussing in this architecture actually, why I'm discussing, whenever you are writing any data in the background, hundreds of servers are working for your request, not one. If it is RDBMS, you implement the load balancing for the application. So you will have a load balancer. Behind the load balancer, you create lot of web servers. It is possible, but all web servers at any point of time should hit one DB server only for the data. You cannot hit multiple data DB servers in the background and write the data in the RDB. Any RDBMS system does not support multiple multiple, writable servers basically. Okay, your even Oracle has rack concept. You can write in multiple servers, but at the end only one storage only. It will update, not multiple storage. You cannot keep it. Oracle architecture is little different, guys. Rack concept, if you some people are from Oracle background, you can understand. So I'm giving the fair idea about architectures, guys, then I'll enter into the subject, that you try to follow the most of it. So now if you take it Oracle, SQL is anyway only one node can be writable at any point of time. In Oracle, you can write in more than one node actually. It is possible in Oracle. You can write here, all these except the read and write basically. But at the end, the limitation is only one storage. You cannot keep multiple. Applications can write, like these are all applications, and why I'm comparing all architecture to get the most understanding first. Then only you follow the further discussion. These are all application servers hitting a lot of different servers for writing the data and reading the data. It is possible. It is possible to do this kind of thing, but the problem is at the end all will go to one storage only, one mount only. It is a limitation. You cannot operate with multiple servers with one data set with multiple storage endpoints. Only one storage endpoint with the Oracle also. So limitation at the end is going to one point in the all RDBM system. There is no way that you can do the write operations on multiple systems, multiple backend points. In all NoSQL family will follow the distributed computing model. Distributed computing model means, see guys, I'm discussing the architecture of RDBMS and NoSQL. Try to catch this point first. In RDBMS, there is a limitation. You can only deal with one system. You can only deal with one system all the time. You're keeping the data all the time into one server, and over a time it becomes too big. When it becomes too big, what happens, you cannot do the maintenance activities like rebuilding indexes, and taking the backup also going to take quite a long, which can which can run during the business hours, or else you cannot do the rebuilding index, so you cannot get the performance. As simple as it is. The query execution plans will go outdated. They will scan the data unnecessarily. It will slow down the system automatically unnecessarily. So RDBMS is, we are not saying that it is not intelligent, it is not sophisticated. It is sophisticated, but the limited data. Not there is no unlimited kind of. If you go with certain amount of example TBs of data like 20 TB, 30 TB, it won't scale well in a single system. Why? Because you cannot do the maintenance activities. If you have a 20 TB database and you cannot do the rebuilding index, it takes throughout the week to do all the rebuilding indexes basically, right? So that should not happen. Come on, this guy is calling now. Just right. So that is a limitation, guys. We have it. So that's something we will overcome with the help of the all NoSQL families. All NoSQL families will follow the distributed computing model. If I'm writing any data, multiple servers are responding. If I'm reading any data, multiple servers are responding at the same time. That's where you get irrespective of the data. 1 TB, 1 petabyte, 1000 TB also it will scale. 1000 TB. One sharding cluster can scale with 1000 TB of data without any downtime, without any delay, because your data is keep growing. You keep add the replica sets, it does automatically balance the data, and you are keeping the data minimal at each replica set. Not, you are not overloading one system basically. That's where you get the good performance irrespective of the data. If you take about Facebook, if you take about Twitter, if you take about any social media, there are billions of people are connecting around the world at the same time. They're getting the good performance. At the same time, they're loading wide variety of data. Someone is writing the comments, someone is loading the video, someone is loading documents or non-editable documents. It is still taking the data. How it is taking the data? RDBMS does not accept. See, let me show this again quickly. I mean, in the beginning, I'm not talking about the slides because I'm trying to give you a fair idea between the RDBM system and the NoSQL systems so that you get the most of it. Try to follow. If it is RDBMS, what happens? So example, let me take one table. Do I have any tables here? Quickly. Okay, doesn't have much anything. Example. Okay, I have a table here. Let me read the structure. So I have three columns into this table. If I'm trying to insert a record, okay, insert into, okay, student values. Just why I'm doing, I'll definitely, there is a reason why I'm doing this. So 16th record example, okay. So username is Mahendra, and three columns we have. I'm just loading it. If I'm running this command, it will take the data because it is matching the structure of this table. If I'm trying to load some extra field, extra column data here, okay, example, some phone number I'm giving it, or else some secondary address or whatever it is. I'm just trying to pass in an extra. It is going to throw you the error. The number of columns applied does not match with the definition. If you want to load some data into RDBMM system, first to define the structure and load the data into the same structure. You cannot violate the structure. If you violate the structure, you cannot load the data at all. But whereas MongoDB, this is a MongoDB UI or a command prompt. I'm into the MongoDB server right now. So I'm going to create one database. Creating a database is just use database itself. It will create a database automatically. Nothing you have to do basically. So I'm creating SQL DBA database right now. And you don't have any collections at the moment, or any tables collection means. You don't have any collections here. I'm creating one collection, create collection. So simple command. I'm creating a collection called lab collection. Okay. Now collection got created. So, okay, there is a collection called lab. Do we have any data in it? No, we don't have any data at the moment. It is an empty collection at the moment. So I'm going to load some data, db.lab.insert. Try to follow. I'm just showing all of this so that you pick up all the further points easily. So example, I'm loading some data here. S number one, S name, just sake of Kumar. Okay, one record. Second record, I'm trying to load with a different structure, db.insert. Okay, this is our minimum structure. Anyway, this will be explained. We have a CRUD operations. I'm going to run 4 classes on MongoDB CRUD operation. How you run the JSON script. It is so simple, absolutely simple. No need to worry. I'll run through everything that you need to know as a DBA. So you just need to follow my classes. So sname, maybe I'm keeping it Naveen, and address. So this is second record. Each record is going with a different structure. It does not matter in the MongoDB. That's the advantage of this. So just try to follow. Address here, I'm keeping it. I'm keeping it location. Okay. Location again, I'm going to keep a location will have, street. I'll tell you, different structure you can define actually. Street, something, OUCU, something, locality. Whatever it is, guys. So if you see, guys, if you see the structure of each object, you find different structure for each object. See, first object is saying that only two fields. Second object, subject means a row here, a document. We call it as a document equivalent to a row. This row is followed 2 column structure. Here, if you see 3 column structure, if you see this one is followed embedded document structure as well as different structure. Every document can be a different structure. It does not matter whatever the structure it has. It will take the data. It does not reject any format of data. You just load it, it will take it. So now this is the first case you need to understand. Second case is show collections. We have one collection at the moment. I'm trying to insert some data where the collection does not even exist basically. Okay, tb.cloud collection, inserting it. I'm inserting some data here. The data is t number one, t name Ravinder, something like this. It has taken the data. So if you see the collection names, it is created the collection on the fly. It does not exist, this collection. The table itself does not exist, and you're trying to load the data. It is created the table on the fly and took the data. So there is no structure definition in the MongoDB. It can just accept whatever the data you're trying to load into the system. It does not reject any system, any format, structured, semi-structured, unstructured, does not worry about it. You load a video, load a PDF, everything we can load into single database, basically in Mongo. So basically nowadays, the data got versatile everywhere. Everybody have a devices, everybody generating the data is not structured. If it is not structured, rdbms does not deal with. That's where the NoSQL is slowly gaining the market a lot. Everywhere you see the mongodb is started common in every company nowadays, because it is following the, or it is fulfilling the most of the business use cases everywhere. It can take any data. All analytical data is processed only on the NoSQL. So what kind of analytical data means? Example, you're going to the YouTube watching a video. So it does the recommendation automatically related to your interest of subject in the YouTube. How does it is actually giving you a recommendation? How does it knows? Every click is recorded. Every wherever it is, every click, every search, everything is recorded. Every user activity is recorded in the background, and that recorded data, artificial intelligence will read that data and give you related other videos on your profile, basically, so that your data will be like in the background somewhere someone is recording and analyzing it and giving you the suggestions. This is something is not manual. It is fully automated artificial intelligence, and that absolutely work with the NoSQL family only, because every data what you are generating through smart devices is not a fixed data. Every time you generate a different wide variety of data that is handled by the NoSQL family products. You got little of idea what exactly NoSQL, what exactly RDBMS. RDBMS always follow the fixed schema model, where if you are trying to load the data into the existing structure of the table, then only it will take the data. Else it does not take the data. If it is MongoDB, even you don't need to create the table. It will create the table on the fly and take the data automatically. So no structure defined, nothing. You just load the data. Every document is different. Every row is different, because there is no definition of the structure. It is schema-less product, dynamic schema model. Just a minute, guys. I have to switch on the right. Let's come back to our discussion now. You would have got the fair idea about it. So now NoSQL represent a group of products and various related data concept for storage. See, NoSQL also have lot of different products to deal with the different data set, different benefits you do get if you go with the different products. Like in RDBMS, we have Microsoft SQL, Oracle, we have MySQL, we have Postgres, Greenplum. Like that, many products have their own independent features actually, right? If you talk about SQL Server, we have always on. Always on, it will protect the server level, where you have this is a DR, but at any point of time you can write only into one server. This is a big drawback. If you move to the Oracle side, Oracle can make you write into multiple servers, but at the end one storage. At least multiple servers is gaining the performance. And all are like RDBMS side has some availabilities, but at the one point of failure, exactly one point of failure in terms of RDBMS. If example, I have like I created a database, the database's files are spammed across multiple drives. One drive went down, one single drive went down, complete database will go down. One file is down means all database, the complete database, whichever is sitting in that drive will be down automatically, because the drive is not accessible, the file is not accessible. MongoDB actually it's not like that. So you distributed the data, one replica set is completely down, still it will operate with the rest of the available nodes, rest of the available data. It does not go down, because these are independent systems. It has independent data. It is distributed and maintaining the data independently. So there is no downtime. You never see the downtime, because it will automatically, it has like you don't see that complete three servers will go down at any point of time. Even if it goes down, 80% of the data is getting operated, maybe 20% is down at the moment, but 80% data is still online. People are working. You never seen Facebook is going down, or Google is going down, or Twitter is going down, because they are running on the NoSQL family only. All these data is running from the NoSQL, not in the RDBMS. Because distributed servers, even one server goes down, there are hundreds of other servers are giving the response with the data. That's how things are working with the NoSQL. NoSQL gaining a lot of market because of it is fulfilling a lot of new generation requirements. These are all new generation requirements. 10 years ago or 15 years ago, there was no Facebook basically. Even it was there, no one was using it. Nowadays, everybody on the social media, every user has account, every user is generating the data. So that kind of data RDBMS does not deal with. That's where these products are shining in the market now. Okay, this is what is RDBMS and NoSQL. We will talk a lot again, but this is a fair idea you need to get. What is the NoSQL family can do, what RDBMS can do basically. RDBMS too good actually. It actually has lot of data consistency. It never run into bad data type. Basically, you load the data, it will be there forever. And if your transaction is failed, it will roll back all of your data. In MongoDB or NoSQL family, we don't have a rollback process. It will load up to the point where it is failed, and you have to verify it, and you have to start loading from where it is left off. There is no option like rollback in the NoSQL family. That is one of the biggest drawback, and the recoveries are weak in the NoSQL family. Like RDBMS recovery is absolutely till last point, you can recover all the time. But in NoSQL family, recoveries are a little bit weak. That is where still these RDBMS are actually gaining the market, and they're running their own product with a fixed schema model as well. If these things are fixed out in the NoSQL family, RDBMS does not make any sense to the market. Why? Because they have a lot of use cases which are fulfilling by the business, but only few things are big negatives are still there. That's where things are not moving. But all analytical data, all transaction data is also still we are running on the Mongo side, though there are few drawbacks. Right. Come back to our discussion. So try to follow the slides, guys. So no SQL means not only SQL. We have SQL, but we have other thing called not only SQL. That is called no SQL. Yeah, we were since ages like 1960s. We are talking SQL a fixed schema model. Oracle was started 1960s, and lately 1980s SQL started. Like without many products started, those are the only the products for the data. Wherever you wanted to load the data, those are the only possible solutions you had. Now things are changed completely. So we only don't have SQL, we also have the no SQL kind of. No SQL means not only SQL, which is another part of SQL. It's opposite of SQL. So NoSQL is a new set databases that is not based on relational database management system principles. It does not follow the RDBMS principle at all most of the time. See, in terms of indexing model, in terms of how the execution plans will be generated in Mongo, it is similar to RDBMS. But product architectures wise, data dealing wise, they are different, not like exactly RDBMS. So big databases, they deal with the big databases, huge databases. There is no limitation on the data set it can handle. As data is keep growing, you keep add number of like a replica set, it'll keep scale automatically. So you need to add more and more servers so that it will just scale with the data, because every node is having the chunk of minimal data, not all the data. So every read responded by hundreds of servers, every write responded by 100 servers. So you don't see the delay, because it is multiple servers are doing the job for you. In all NoSQL family, this is the architecture. Right. New SQL, new generation and third generation. These are all latest generation data. See, these are not for old, like flat file you have it, your fixed schema, fixed data. You don't need this. It is for the new generation. New generation means people have wide variety of data, versatile data. They're loading, like if you see, even the applications also become very agile nowadays. RDBMS, you have a 1 TB table, you wanted to alter the structure, you had to take the lock on the table, you have to do the change, and then do the data load. So it is very hectic job. So nowadays application natures are changing very rapidly. You are introducing more and more fields, because the requirements are ever growing every time. When it is ever growing, you have to alter the structure. If the table is a huge, changing the table structure is very huge headache basically in RDBMS. So that is also another drawback, where this slowly the MongoDB, the NoSQL side, people are showing the interest nowadays. Okay, so these are all third generation databases, means latest technologies, not the old technologies. They can deal with any amount of data, any variety of data. That's the advantage with the NoSQL family. These are all not relational. Not relational means if you see, I have loaded one record and this record is different, this record is different. There is no relation between the record to record. Structure wise, I'm trying to say, structure wise, absolutely every document, every row is equivalent to document. Every document is independent. There is no structure defined at the collection level. We can define the schema. That something will come in the schema design. Though there is no structure, we can keep the restrictions. You have to follow this structure, then only accept the data. That is something comes in the fourth module, schema design, schema validations. We can restrict the data not to accept if this is not following this column structure. We can do that, but by default it is not there. That is a requirement. Requirement means you get this data, then only accept the data, because of it should follow that use case. But by nature, it will accept any kind of data unless you are not imposing the restrictions. Non-relational means it does not have any relations between the document to document, collection to collection. There is no join concept. There is no join concept in Mongo. If example, you have a student name, student details, student subjects, where he is, what are the subjects he is taking, what are the courses he is taking, what are the phone numbers he is having, what is the address he is having. Everything should go into one document only. You cannot load one person detail into multiple documents and join it. There is no join concept. Every document is independent. One document should hold all information about that person, as simple as it is. One single document take like address, phone numbers, is secondary addresses, primary addresses, everything will go into one single document. You don't deal with, if it is RDBMS, you maintain the address somewhere, you maintain the contact details somewhere, you maintain his personal details somewhere, and you join the tables, keep the relations, and at the end you get the data. But in MongoDB there is no such thing. Everything into one document. So that is something, another big advantage you get it with this. It is unnormalized, like it is not normalized data. Runs on commodity hardware. See, if it is a RDBMS system, you run only on one system. And if it is not sophisticated server class hardware, you cannot scale. If it is not, you have large volume of data, you definitely have to go to the SSDs, solid state disk. If you don't go with, it won't scale. Normal hard disk cannot scale because it will have a limited IO capacity. If you go to the solid state disk, they will definitely process the data because data is more. As the data keep growing more and more, you have to go with upgrade your hardware, then only upgrade in terms of CPU, in terms of memory, in terms of hard disk as well. If not, it won't scale. Why? Because the limitations on the hardware. If it is a MongoDB, it runs any hardware. You don't need to go with the highest server class model. Basically it will run a normal hard disk also. Why? Because you're keeping the data limited on each node, not too big data, right? It runs on the commodity hardware, means cheapest hardware. You no need to go to the server class hardware, basically, because data is distributed into multiple systems. Basically, you can keep it normal desktop and start striping the data into it. That also will scale because it has a limited data. It does not have a TBs of data in a single system. So that is where big advantage people are gaining. Commodity hardware means cheapest hardware. Open source, this is a very very big point, guys. All NoSQL families are open source, all. And it has the licensing versions also. In MongoDB we have two editions, community edition, enterprise edition. Community edition absolutely scale with the 1 petabyte data also. 1 petabyte, there is no limitation in terms of data scale in the community edition. We are running maybe roughly 50 db, means 50 into 90. We are running on one cluster on community edition itself, 50 TB. 50 TB means by default data will compress in the background. All MongoDB products, all NoSQL products, what it does basically. This is also another big advantage we have. If it is a RDBMS system, whatever the data is in the database, it is absolute data. If example I'm loading 10 GB, it will occupy 10 GB storage. In MongoDB, what happens? There is default compression is there. If I load 10 GB data, 10 GB data, if I'm loading it, it will convert the data in the disk 1 GB. 90% compression, snappy compression, it will follow by default. I'm going to talk about compression types. We have multiple compression types. glib compression, snappy compression. glib will compress 10 GB data into 500 MB or 200 MB. It will compress that low level. basically. Whatever the data you see in Mongo is absolutely compressed by default. RDBMS does not support that. You have to explicitly compress the data if you want it. That too, you have a table level, row level compression. Okay, table level, it is not database level. You have to compress it table, you have to apply that at database level. We have a page level compression and row level compression, if you guys are aware of in the SQL Server. But in the RDBMS, you no need to apply that. It is server level feature. You apply in the config file, it will automatically compress the data automatically. So there are a lot of advantages, guys, with the NoSQL family. Lot of advantages, seriously. And this is open source, means in community edition, community and enterprise edition, two editions we have in the Mongo. Community edition equally capable of handling the data like enterprise, but there are few features are deprecated, like no automatic monitoring, no inbuilt backup mechanism, no encryptions. There are certain, like major features are taken away from the community edition, which is free. We are running 100 plus production servers on the community. Only 10 or 15 servers we have on the enterprise. So 90% of the infrastructure in our environment are on the community edition, where the client does not pay single rupee to the Microsoft MongoDB. Only they pay for the support. So in case of if it RDBMS, they will give the open source, like we have a Express edition in SQL, Oracle also we have some editions. There are quite limitations. SQL Express is open source, there is no charge, but it can go up to 10 GB only. Beyond 10 GB on database cannot perform, cannot take the data anymore. Even it takes, it won't work basically. So there is absolutely, basic cutoffs are there, very limited cutoffs, very limited. The free editions are open source, but in the NoSQL side, there is a community edition in the Mongo. It can scale with 100 TB or 200 TB, 300 TB, does not matter. Only what you are not getting is automated functions, inbuilt backups, or automated monitoring, encryptions, and some like security layers are missing. Some few features are definitely they are not giving. Why? Because they also need money. They are giving the product, they need the money. So you have to go to the enterprise for certain critical products, right? So that they get the good amount in that enterprise edition part. In enterprise, you get the tools basically by default. They'll give the free tools like Atlas, Ops Manager, and Cloud Manager. There are three tools which are only work with the enterprise versions, not with the community edition. Tools are free, and you get the good sophisticated features, more security is embedded into those enterprise version. But data management wise, absolutely as good as enterprise, except the features. That is where these products are taking the people, like interest in the market. See, if nowadays multi-profiles are so popular in the market, and multi-profile is one must have a one NoSQL product in their profile. That's where the market is growing now. Even you are working with one RDBMS, you should have one NoSQL product into your profile. You get the good openings. It started like that. The trend is started like that. You have to upgrade to the with the market, of course. So open source means that. Schema less means, guys, there is no schema. I was saying this, I was showing the data, like loading data, and I was loading some data without a collection, without a table. It is created automatically and loaded the data into it. So there is no schema, nothing. You don't define anything. It will take the data on the fly. Dynamic schema or schemaless, two words are same. We'll call it a dynamic schema or schemaless. Highly scalable because it is running the data on multiple distributed computers, not one computer. There is no one computer. When we have a huge data, you definitely go with the sharding. First you start with one replica set, guys. Like one replica set is like one RDB, traditional RDBMS availability, like always on. You write one data and the others will be standby. But as the data is growing here, you start building the cluster, and cluster will start taking the distribution of data. So that's how the, like when the data is not capable of processing from one machine, you start building the cluster model, then automatically data will stripe out and it will absolutely function, though the data is becoming bigger and bigger basically. So that is where you get the more scalability, more highly scalable, because more computers are giving the response. Highly available, this is also another part. Every chunk has, see, this is one chunk, like we said 100 GB means 20 GB is here data. So 20 GB is one chunk. This is one chunk, this is another chunk, this is another chunk, another. One chunk has its own another three copies of the data. One, two, three, three copies of data. If one goes down, it is automatically failover. I'm going to do this configuration. I'm going to show this how data is also moving in the background. That also we can see, visualize. We can visualize how data is moving from one node to other node, how it is balancing, how much data it is moved. Everything we can trace. I'm going to talk about all of that in the course anyway. But anyway, try to understand here. Even highly scalable means every replica has its own standbys. Even one server write copy is gone down, other server will come online automatically and start taking the response. And complete replica set is down for some reason, you still operate other part of the data. There is no complete downtime. Absolutely all will not go down at any point of time. That is called highly available compared to RDBMS. Highly available supports base properties instead of asset properties. Asset properties actually gives, like more security or more data consistency. Base will have a little bit of, loose consistency in terms of this property. We'll talk about this at the end of the slide. I have the discussion on this part as well. Mostly runs on the cluster. You have to run on the cluster to get the benefit of this NoSQL family. If you're running into one system, there is no advantage of this product. Why? Because it allows distributed computing model and you're not doing it. If you're not doing it, you're not getting the benefit. That's why if you have more huge data set, you definitely run on the cluster environment. Built for new generation applications. New generation application means, see, nowadays things are agile. Every time, like every day new things are coming in, new fields are adding to the application. So when you have to apply the new fields, you have to define the structure in the background. If it is RDBMS, if it is NoSQL, absolutely no, just add it and then do it. It will take the data in the background automatically. You don't need to define the structure. That's the advantage. That is what called new generation applications will use these products. So why NoSQL again? Why NoSQL in the market is growing? Resolves the challenges faced in storing, managing, analyzing, archiving the data. So, example, you are running a business, you are getting large volume of data and data is keep growing. You don't want to keep the data in the live system. You want it to archive into different server. Okay. You wanted to if we are doing this, this is a good point I got into mind. See, in our SQL server, what we are doing is we are migrating all historical data to the MongoDB. All historical 10 years below or 5 years below based on the product into MongoDB. MongoDB is generating and giving the reports to the clients through the Tableau. There are multiple BI tools basically. Tableau we use a lot in our environment. And Tableau generates the report and we can send it to the clients automatically from that tool. So if you wanted to see MongoDB, very versatile product, it can take the data from any product. I have done a lot of migration from SQL Server to MongoDB. I have involved in it. I'm going to show that how do we do the migration from SQL Server to Mongo to SQL. So just for a simple example, I will tell you. So example, I have this data in the SQL Server. I wanted to migrate this data into Mongo. You can do on the fly. That's how every product is actually immediate connects with the Mongo and load the data. Oracle, SQL, Post, whatever it is. That is something is a kind of versatile target for you. I'll simply show this once because we do data migration from SQL to Mongo on the fly when they request. How do we do it? So select asterisk from, okay, student, okay, for JSON auto. It will generate the data in the JSON format and in the MongoDB data format. See, this data got converted into the table data, complete table data converted into this structure. MongoDB, this is something document model, we'll call it as. Now I wanted to load this data into Mongo on the fly. db dot, okay, I'm going to keep it as testing collection. Okay, insert many. You have to keep this function. That's it. Many and parenthesis. Now I wanted to migrate this data from SQL Server to Mongo and just pick up this query and go to Mongo and run this query. It will take the data automatically. So you migrated data from SQL to Mongo on the fly. Dot find, you get the data here. See, the SQL data converted to Mongo on the fly because Mongo deals with the JSON file format or data format is accepted by all products across all RDBMS, NoSQL families, every product. That's where the Mongo become the versatile nowadays. You can move the data to any product from Mongo, take the data into Mongo from any product, because of the it supports JSON format data. JSON is supported by every product basically. You can on the fly migrate the data like this. There are tools. If you have huge data, you cannot migrate like this. We have a tools. How do we migrate data to Mongo to SQL? I migrated a lot of migrations. I did in that direction. So I'm going to talk about the tools, migrations, and all that. See, this is not what is what. My courses are not what is what. I'm going to share all my experience that I have gone through. That is a big advantage for you, because I take out all my real time situation scenarios. I'll talk about that, I'll show you that, I'll create the situation, I'll intentionally create the situation, and I'll figure it out, I'll fix it. Every technology will go in that direction only. Okay, you have to be regular to the class. That is the only thing, right? Come back to the discussion. Explosion of social media data. So Facebook, Twitter, with a large data sets definitely need a the MongoDB or NoSQL, whatever it is. So you definitely go to the MongoDB side or NoSQL side to deal with the actual data. Okay. So need of continuous availability. All social media platforms need a continuous availability. If not, someone else will build their own social media and they'll give the availability. All people will migrate there. To sustain with it, to sustain with the system or business, you need to give the continuous availability of system. If not, you're gone. So continuous availability comes with the distributing computing model. With every copy has its own again protection at the chunk level. Need of more flexible data model. It is absolutely flexible. You can load any kind of data. It is by default, by nature, it's a flexible. So no need to say that flexible data model kind of. The NoSQL database, great solution for the growing scale of databases and falling price of commodity hardware. See guys, when we were in the 10 years ago, if you wanted to buy 1 TB hardware, 1 TB hard disk, it used to be 10,000 above. 10,000 rupees you have to pay for the 1 TB. Now 1 TB will come 3,000, 3,500. 2 TB will come below 5,000 basically. The hardware cost is falling down. So when the hardware is computing model is coming down, you are running the on cheap computing model, on cheap hardware, because you're distributing the data. So you can invest less on the IT side. No need to invest server class hardware. Okay, so that you can save the money. That is what this point is talking about. The hardware charges are coming down and data is growing. So for data growth, you definitely need a storage. So as the storage is growing, you need more and more storage. More storage is actually coming at cheaper cost. So that is where this is a ready-made solution for the people. Consists of column-based data stores, key value pairs, and document bases. There are many kind of products we are going to talk about. It's not only document. This is a document base and key value pair and columnar base. We have different products again to deal with different data. Offers capabilities to handle large volume of data using various available features. That is what I was talking about, like data compression by default. It runs on the commodity hardware. It will deal with the distributed computing model. It is a schema-less dynamic schema, and these are all major benefits if you talk about why we need a NoSQL, right? So let's move on. NoSQL database overview. See guys, the main benefits of it I was talking about in just few seconds ago. Continuous availability, no single point of failure. It will try to make the system all the time up and running with a high available, high scalable, everything is given. If it is RDBMS system, one file goes down, your database is gone. Write copy is gone, and the read will take the immediately, or depends on you have a read copy or not, or depends on that. You have always on, one database is down, always on does not do the failover. It only detects the server service level basically. If one database goes down, it will go to not synchronizing. It does not have that level of protection at all. So where do you stand then? Your business is down, right? In MongoDB, it's not like that basically. Things, one single database, one collection is striped out. If one chunk is down, other chunk will operate. There is no single point of failure. That means here single point of failure you have it. That something is not good, right? That something is you did not achieve with RDBMS. Continuous availability is not achieved. No single point of failure is also not achieved. Both are achieved with the NoSQL family. Multi-data center capability. Multi-data center capability means you keep two nodes This is one more point you need to understand. You keep two nodes in one region, two nodes in one region, one node in another region, other part of the globe. It will sync automatically. If these two servers are down because of the complete this region is down, come on, complete region is down, you can operate from here in the remote region. It is possible. I'm going to configure multi-region servers. We're going to see the migration of Mongo from one region to other region. We're going to see all upgrades from one version to other version, the challenges that we face, the process what we do, everything will be covered anyway. So it will follow the multi-region replica set. Like one few set of servers you keep in one region, other set keep another region for data safety. But chunk is also important. You go with this like you are dealing with the critical data. Two servers keep in the local, one server in the remote. So these deal with the data. If this goes down, this will become primary. This goes down, this will become primary. If both goes down, you have the data here at least. So like that, multi-data center capability can be done at replica set layer. Easy replication for distributed location, independent capabilities. You can easily distribute, guys, because the computing model is distributed. The data also getting distributed to different data centers. High performance with a linear horizontal scalability. See here, if you talk about this thing, guys, this is you all know anyway. This is called all RDBMS is called vertical computing model. Vertical computing model. We'll call it as vertical computing model. Why it is vertical computing model? We are actually, if you know, loading the data into one server, you keep upgrading the hardware in the same server to scale with the data in single server, adding and more resources to get the speed. But here we are, this is called vertical scaling, adding in a single server. Here horizontal scaling, if data is growing and growing, we are adding the replica set, we are adding a different computing model. See, it is horizontal, we'll call it as horizontal. Why? Because we are running the data on multiple servers at horizontally. Horizontal computing model. All NoSQL families follow the horizontal computing model, means distributed computing model indirectly. Horizontal model. Okay, right, we'll see this. So this is the point it is pointing at on is performance linear horizontal scalability, because you are adding one set of server. When the load is keep growing, you're adding more and more servers to take the data load basically. Okay, this is called horizontal computing model. Next, flexible schema support. Just we talked about here with a lot of example. It is flexible enough to see. I was loading the data of this testing collection. It was not created. It is created the collection on the fly. It took the data, whatever the structure. It does not look for the structure. It accepted it as it is, and it loaded the data as it is. Okay, that is called flexible schema. Basically, you don't need to worry about the schema. It will always taken automatically and dynamically. Easy to implement and maintain and grow. The commands are very simple. One single command does lot of configuration in the background. Replica set is only two commands. Two commands will form the replica set. One command will make the sharding. So configurations are easy, dead simple in Mongo. Very simple. Anybody can understand. Only you need to understand the architecture, the background operations to support the actual issues. Basically, configurations are very simple in Mongo. It's not tough. That is called easy to implement. Thriving the open source community. All MongoDB products are, or not only NoSQL family, all NoSQL family are open source, and all open source will support maximum amount of data, not limited. But except the features, features are missing on the open source. Every product has enterprise and community, or whatever they call it as open source. But enterprise will give you all the options like monitoring, auto inbuilt backups, and encryptions, and all security features that you need in your business, but not in the open source. That is everywhere it will be there. But they, so handling all the features, like all the technologies, like you can implement replica set, you can do the sharding and everything you can do in the open source. That's a great advantage. Okay, you protect the infrastructure from network side and run your data in your open source. It is absolutely fine. It is absolutely fine. That way you can achieve and save the money, right? So this is what RDBMS and versus NoSQL. So this is a fixed rigid schema. You have to define the schema, then only load the data, then only to accept the data. Dynamic schema, it is always dynamic and schemaless, no need to define it. Vertical scaling, just now I was talking about, this is something is vertical scaling. You load the data into one system is taking the data, more and more resources we add it. Vertically means to the single system. Scaling up, giving the more power to the machine, to the single machine. That's why it is called vertical computing model. All RDBMS are absolutely follow this model, and all NoSQL families follow the horizontal model we talked about just now. Default to handle the difficult to handle the big data. Sorry, you cannot handle too big data in a single system because you cannot do the indexing. The maintenance part becomes very tough. If it becomes tough, you don't do the maintenance time to time, you absolutely go out of performance, right? Performance is not there, system is waste. Like you need the data, you're not able to get it, then absolutely waste, right? There it won't suffice. The RDBMS does not meet the requirements of the market. It can handle any kind of big data, petabytes of data you can operate on the MongoDB, and by default it will compress the data. That is another big advantage. All our DBMS system does not compress the data by default, and compression is also at particular table level. You have to do it, row level, page level. You have to apply that. Then only it will compress the data. Else it does not. But Mongo at server level, it will compress everything that has the inbuilt capability. Mix of open source and proprietary. Most of proprietary, open source will be there, but they are very limited in nature. If you go with the community, it will only use 2 CPUs and 10 GB. 1 CPU, in fact, not 2. 1 CPU only. You have 10 CPUs, still it's useless. Why? Because open source can use only 1 CPU. You have large volume of disk, but there is you cannot use it. 10 GB is only limitation. Limitations are very low level. Here there is no limitations. You can grow up to whatever the point you wanted, except the features that you wanted, you won't get it. But data scalability, you get it. Mostly standalone, always distributed if your data set is big, and single point of failure. Of course, if one file is down, the complete database will go down. It's no single point of failure. Even one chunk is down, other chunks will operate from the other nodes. Asset properties, base property, I'll talk in the next slide what it exactly asset and base. And need server class hardware. It needs so sophisticated hardware because you're running everything on a single machine. If the hardware is not good, it will choke there itself and you don't get the outputs. You don't get the good IO. Good IO means you get the latency. At IO level is also because data has to come out of the disk. Then only it will give the response. So that will be slowed down. Costly and average. See, if you are running one RDBM system, you can run 10 Mongo servers, equivalent to that cheap it is. Even enterprise also, enterprise become very, very costly nowadays. Any product you talk about. In RDBMS model, enterprise versions are damn costly. Okay. And you run MongoDB with one cost, while as in 10 Mongo servers you can run and on enterprise side. If you compare a big data structure and licensing model. So that way also you are getting the benefit licensing wise. Types of NoSQL. You have Redis server, Memcache, Scalaris, and MongoDB, Couch, RavenDB, Bigtable, Cassandra, HBase, Hypertable, Infinite Graph, FlatDB. These are all different products. Like in RDBMS also, we have a lot of things, right? I was saying Microsoft SQL, Oracle, all that, etc., etc. The same thing here also we have it. But why MongoDB become so popular in the market? Because it is fulfilling the most business use cases in the market raised by the customers. That is where Mongo got popularizing, are getting popularizing, and it is implementing everywhere in the market. That's something just keep in mind. So big data means, see guys, big data is any data that can be handled and processed through the traditional systems. Any, you don't need server class. You can run on the commodity hardware or cheapest hardware. It will scale because you are keeping the limited data in each chunk, and it involves millions of users depends, like number of machines you keep deploy, it will scale with all the read, with all the writes. That's how millions of people at a time can process the data and read the data and write the data. Millions of queries, billions of rows of data they are reading, variety of activities at the same time, read, write at the same time, still it accepts and process it. There will be locking system. How the locking work in the Mongo we'll discuss in the modules only. How Mongo system locking mechanism will work, which actually how do we find the blocking sessions, how do we rectify the issue. So that is comes in the performance. I'm very expertized towards performance in the Mongo. I can show you the execution plans. I can tell you easily which query is taking time, which query is bad. We can trace easily. We can find performance issue on the fly. That level of performance tuning I'll cover. You have to be regular to the class. That is important. See, guys, big data gives best basically in terms of volume of data. It can take a huge volume of data. It can process variety of data, structured, semi-structured, unstructured, whatever it is. It can accept the data and process it. And velocity, speed, the speed of giving the response is too good. Why? Because it is running on the distributed computing model. Vertical scalable, which is for the RDBMM systems, increase the CPU, RAM, disk on the same machine, but high cost because more CPUs, more licensing model, more money you have to pay it. And downtime, you wanted to do some activity, you definitely need a downtime. Basically, in the cluster model, we no need a downtime most of the time. You do the downtime on the secondaries, failover, and do the on the primary. So when it is online, but you take the downtime anyway, but minimal downtime all the time, right? And threshold and limitations, RDMA does not scale with a huge chunk of data sets, so there it will be a drawback. Single point of failure, one file or one table is corrupted, one more than 1,000 pages are corrupted in RDBMS database, it will go down in SQL Server. 1,000 pages minimum. It has to corrupt 1,000 pages. It will directly go and like in recovery or suspect mode automatically. Okay, so 1,000 pages is equivalent to maybe 1 GB itself. But here you are losing a whole chunk of data. Still, whole chunk means whole replica set is down. Still, other replica sets operate. That's another advantage. And if it is this is an RDBMS model. This NoSQL model. These are all horizontal scaling. Add more machines, not the more CPU and memory. It's more machines and less cost. Runs on the commodity hardware, no downtime because multiple servers are there. No limitation of the data. No single point of failure. Can be scaled down means it can scale up, scale with any amount of data as you keep add more and more machines. So that is where you get the. This is what I was talking about all the time, right? Next, right. This is what I was saying. I'll talk about what is asset properties, what is a base model. So atomicity, what exactly is atomicity? Atomicity is make sure that every transaction should not left in the off done status at any point of time. Transaction either roll back or roll forward. It should not be left in the off done status. It should not. Consistency, what is consistency? Will make sure that if you're doing a transaction failed in between, it has to roll back if it is a batch. If it is example server is all of a sudden rebooted, it when it comes online, it will verify where the transaction left off. It will roll back or roll forward based on the transaction status in the log file. The consistency will take care of all the possibilities of failures and auto and unexpected shutdowns. It either take you the data to backward or forward, but it will take you the right data, not the wrong data. This is ongoing transactions. This is something unexpected events. It will handle that. Consistency means it will keep the data all the time same, and what you load into the system, it is accepted by the system. Isolation means one at a time, one table, one you are writing the table on one table, you cannot write another on the same set of records. Locking levels are again, guys, DBMS row level, like a page level, then table level, lock escalations that comes in a different topic of performance tuning. But anyway, isolations are specific to what chunk of data you are writing. That chunk of data is absolutely locked for that operation. Other operation cannot do on the same thing. That is called isolation. Is definitely required to keep the data consistency. Multi people are writing at the same time, you go into inconsistency of data. That should not happen. Durability means whatever the data you load into the system, it will be there forever. It does not change on its own. It will be there what you have loaded. So these are the properties are actually given by the RDBM systems. Basically, like this is where these kind of things are definitely required by the business. So it will follow the NoSQL will follow the base model, basically available soft state eventual consistency. What exactly this means? So we do all the right operations from the primaries in replica set. If it is not a starting model, come on. If it is not a starting model, you write the data here, you read the data from there. But here to here, asynchronous, there is no synchronous replication. Asynchronous means it will sync the other copies based on the network availability, based on the system availability, right? If it is RDBMS, you have a synchronous and asynchronous, you can define it. But here you don't have a synchronous asynchronous concepts under your control. We'll talk about this a lot in the further. Then MongoDB. MongoDB, actually the old name of MongoDB is Tengen. Initially, before 2008, I guess, I'm not sure exactly the year when they renamed to MongoDB, but MongoDB used to call as Tengen. The same company itself, they termed into MongoDB Incorporation now. So the MongoDB is developed and done, everything, every development is done by with them only. So the distributions, community edition, enterprise edition with the MongoDB only, no third party. If you take about any kind of Postgres has a lot of distribution models. Like Postgres is open source, anybody can take the product and sell it. EDB, we have enterprise DB, right? In Postgres, EDB actually they have giving, they developed it and they are actually selling it, selling with the licensing cost. If they can support if something goes wrong, right? So that is something is take, open source is something given by the Postgres company, okay, but someone is taking it as it is open source, someone is taking, developing and selling it off. But MongoDB is not open source for anyone to develop. It is for only for MongoDB. It is open source given by them only, not by someone else. No other distribution, only from MongoDB. Community or enterprise should come from the Mongo only. So the old company name is Tengen. The new company name is MongoDB Incorporation. They renamed it anyway. It is object structured documents, JavaScript notation will follow. This is called JavaScript notation. This is called JSON format. JSON means JavaScript notation. And manipulations with objects, collections, you can do all sort of operation that you do in the RDBMS. There are few things which are not there with the system. Recoveries are weak in the NoSQL side, and the transaction rollback process is not there in this one. These are the major disadvantages we do have. So along with this, guys, this is kind of demo to understand what is NoSQL and SQL or RDBMS. Along with this, most of the people are from non-Linux background. In my classes, I'll cover complete Linux administration, what we need to know as a DBA, next class onwards. First, I'll pick up the Linux basics, then I'll enter into the product. You no need to worry. This course does not need any prerequisite except you should have one DB technology into your profile. This will be an immediate add-on to enter into the job profile. This is a hard cake in the market nowadays. Why? Because it is widely implemented nowadays. You check it out, guys. In the market, everyone is using the Mongo everywhere. So I'm going to take you through all the Linux basics that we need to know. 4 classes will be there on the Linux platform itself. I'm going to build from the building of machine. I'll give the machine, I'll connect one-on-one and configure the machine after you guys pay the fees. On the configurations, everything I'll do one-on-one. It is absolutely, like I'll give importance to every single in the every single individual in the class. You have to be open up. You try to ask your questions. So it's not should be one way of traffic. I would recommend and keep ask everyone to just keep coming up with your questions. As long as you don't have a question, voice is low. Voice is low, guys. Actually, come on, I have seen just now.
Ravi, we
Yeah,
have
go ahead.
some query.
Yeah, go
I
ahead.
have some. Okay, in SQL Server, we are storing the data in MDF and LDF format. Okay,
Right.
so all that data is storing in the as kind of the data pages inside the
Right.
MDF and LDF.
Right.
Okay, in a Mongo, how data is storing in which format?
And data will show us, load into the chunks actually. Like each document can grow up to 16 MB. There is no page. You have extent. You have file groups and all those concepts are not there here. You have a
Uh,
collection. Each collection have a document. Document can grow up to 16 MB. That's it. So what
Wait,
I
wait.
mean is,
Sorry. You use two words, collection and document. Okay.
right. Hmm.
So collection means if
Collection means
any.
table. Collection means
Okay.
table. Document means row. A row.
Okay.
A row is
Documents.
called as a document. A row can grow up to 16 MB maximum. If it is not able to load into, you can go with the Mongo file. There is a separate binary where you can load any big file. Like you have a video, PDF, such kind of files will be more than 16 MB, not text file. You have a one more binary you using which you can load the data into database. Like 1 GB file, it will load as a single file into, it will divide the data into multiple chunks and load into Mongo. But there is no storage architecture like you have a page extent and all that.
Okay, okay. So it means collection is mean table and Mongo is a document.
Document,
So
yes.
so as per application requirement, we are creating multiple collection, and according to that, we are inserting the data on that collection. Correct, no?
It's exactly like, tables in the RDBMS. You are creating multiple tables and loading the according data into each table. Here, multiple collection means multiple requirements. So you are loading into the each collection the data into it. Collection is like a table. So how many collections
Okay,
you create depends on the requirement. Like absolutely like RDBMS in terms of collection.
okay, okay, got your point. And you showed the architecture for Mongo that
Mm,
4 or 5 servers are there, and storage is divided according like 250, 250. Suppose we have 4 server, and
mm,
storage is divided by 250, 250 each server. Correct, no?
mm.
So
That's correct.
inserting the data, suppose we are inserting any data. So
Mm.
data insertion is happening from starting, or randomly any server he can pick.
See how it
How?
happens. Let me tell you. Good question anyway. So you have 100 records here, 100 records, and you're entering 1, 2, 3, 4, right? One will go to here, two will go to here, three will go to here. It is a parallel write. Four, again 5, 6, 7, 8, 9, 10. Like this, it will go in the round robin fashion when you are writing itself.
Okay, okay. It means it's not storing in a single server. It is storing
Yes,
with storage separate.
yes. Parallel write, parallel read. Both are there.
For application automatically it will decide.
Can you come again?
Gunath here. Okay, so
Yeah,
actually what I'm saying is the parallel write and parallel read and parallel it will automatically the MongoDB process automatically decide or how? Is it-
you have to
So
do that. You have to tell the Mongo like do the sharding on this collection, then only it will do. It is a collection level technology, table level technology.
table level document. So
Yeah,
okay,
collection level, not database level. It is a collection level technology. You wherever
collection level.
whichever collection is growing bigger, just enable the sharding. It will distribute the data automatically. Smaller collections we don't do it. Why? Because
Okay,
they have limited data.
okay. So if initially we are setting the production server, shall I we recommend for starting for initial stage for production or
No, initially no. You need to look at the data trend growth. Based on that, if
okay,
it's really growing bigger, then go for the sharding. On the fly, you can convert the replica set into sharding. How do we do that? We're going to cover that.
okay, okay, okay.
That
Okay,
is a
thank you.
fully configuration.
Yeah.
Yeah.
So actually, I want to know that you already said that enterprises edition and community edition, like right?
hmm
So many companies whether using for community or enterprise.
See, in our case, 90% is community. 90% because we no need to pay. 10% is enterprise, where we are running with the financial data there. So we don't want to compromise. So
Okay.
90% is a too big advantage, right? You're no
Mhm.
need to pay single penny. 10% only you're
Okay.
paying, so you're saving a lot of money in this. That's how it is.
Okay. Okay.
So
Thank
sharding is supported in community version.
Yes, we are running the sharding in community, lot of shardings and community. Yes, with large data sets.
you. Okay. As you told, the MongoDB have some tools like Atlas and Ops managers like that. Okay. So these
That
are the
also will be
license
covered.
model.
That also will be
Oh
covered
no,
as per
what
our.
I'm asking. Okay. Okay. So is the same part of the tool can we get for open source also? Because we are
No,
not
no, no,
going for
no, no.
license.
They are only for enterprise, not for open source.
Okay. Okay. Yeah.
You
Thank you.
see, if they are giving everything at free, you don't go for the licensing model. If you are not going for my licensing model, how do they get the money? Because they are investing their time and money in it, right?
Yes, okay. Yeah. Thank you.
Yeah, good question.
Yeah,
Any
if at all we want to monitor, like, will there be any third-party tools for the community edition?
No, only manual monitoring. How do we do that? I'm going to cover. Community editions, you don't have monitoring. Absolutely, you don't have. In third-party tools are not there for Mongo. Only Mongo tools are. Mongo Incorporation is releasing the tools which are called Atlas, MongoDB, and Cloud Manager. These are the three tools which will incorporate with the enterprise edition, not with the community edition. Because they are giving it free of cost, then why do you support all of that? Go for enterprise. you pay it and you get it like that. But you have a lot of things in community edition to monitor yourself with your own scripts. That is something I'm going to cover anyway.
Ravi, is this possible to to backup and restore single document in this Mongo?
A document, you have to take document level restore is not there. You have a collection level, you have a database level, you have server level, everything, but not the document level. Document, you have to take out the insert. Actually, you have to take that into how do if you wanted to take the document, read out and then take that, copy paste and do it. There is no document level kind of.
Okay.
Read the data, it will come out, copy and paste and run on the target. It'll build the one document. One document is simple, right? But document level
Okay.
restore is not there. Restore is not there.
Okay. Collection level we can backup and
Yes,
restore.
yes. In RDBMS we cannot do the table level backup and restore, but here we can take the table level backup and restore.
Correct. This one.
Yeah.
And
Any
the
other question?
transaction rollback option is not available na, in this one.
No
Suppose
rollback. By default, it has implicit commit. You load example 1000 records. It is failed at 500 record means 500s are inserted. It won't be rolled back. It will be inserted. You have to verify that how long it is succeeded, and whatever is where it is left off, from there you have to load yourself. There is no rollback. Clear?
okay. Means out of the 1000, suppose 500 records is inserted, so we need to check manually. 500 inserted, rest is pending, so we need to follow rest of the
Right.
one.
That's correct. That's absolutely correct what you said.
Okay.
Any other questions from
So
anyone,
it's
guys?
very difficult now, because
Yeah, but you need to track, like it is simple, right? You can read the collection until what point it is executed and find it out and load data from where it is left off. That is something a developer job anyway.
got your point.
That's where, the RDBMS is strong in that direction. Here it is weak. Okay, guys. So see, guys, this is not only the, just what my course is absolutely practical oriented. 90% I'll go with the practical. Theory, I don't talk too much. I talk through the practical. First practical, then theory. Theory, I don't talk first always. Because if you understand practical, if you visualize it, you understand theory very easily. I always do the practical, come to the theory. That is how my training sessions are. Very limited theory, but practicals are absolutely real-time oriented. Whatever I faced, whatever I involved in all migrations, in all upgradations, in all performance tunings and data center migration, cloud migrations, and with different platforms, how do we integrate this product and all the basics, everything, guys, in and out of Mongo, because I'm working on since very long on this product. I know most of the stuff what we need to know as a DBA. And along with it, we also cover the development. 50% of the development I'll cover. 50%. So you understand, if if I are deploying something into the system, you need to know why you're deploying it. What is a business requirement? So a little bit of idea. That also I'll give a fair idea to understand the scripts. Performance tuning, especially I'm strong into this side. Performance tuning in the Mongo. On the fly, we can catch the issue and then find it and tell to the business. How do we find on the fly? I'm going to talk about, because this is very strong area for me, especially in Mongo. Everywhere I'm strong, but this is something I'm really interested. I actually involve into any escalations into performance of Mongo. Okay. So any questions before I stop the video?
Yeah, so this is mostly the JSON data type, like so someone should aware about JSON, or
No,
we learn on the fly on the
it
course
is
going.
so on the fly. You can learn it dead simple than TSQL compare it. It is dead simple. I'll take 4 classes
Mhm.
on this one. Everybody can write their own script, not what I'm saying, because it's such a simple thing if you follow it. I'll tell you right from the basic to advanced in the 4 classes. You don't worry about that.
So that helps to as a from the developing perspective.
Yeah, if you are interested, yes, I do some development also for, development means I don't do, but if some developer is asking some question on some code, yes, I do the advices because I know it. I'll get
Okay,
you
okay.
that level.
Okay, Ravindra, just I want to ask how the Mongo NoSQL is suitable for big data. In the document we have shown that big data, right? So whether it's
Can you come again? I didn't catch your question properly. Can you come again? How you
will you please show the document?
document? Okay, this is a document.
No, this is not a document. You have shown one Word document, right?
Okay, Word document. Okay,
For NoSQL and big data technology means for what? The job opportunities in the market for NoSQL and big data technology.
NoSQL. Since the beginning, I'm talking about how it will handle the big data. Means huge data. Huge data. That's it. Since the beginning, we are pointing that only. Big data means huge data. It will handle with the huge data because it is following the horizontal or distributed computing model.
Okay. Thank you.
Yeah. Any other question? Stay back. We'll talk. I'm stopping the recording.